Remember not to write all your math papers in ink. Remember to show all your work if you don't want to see. Remember to test, stay, and prepare for a holy.
All right, 1.46, they call this factor the perfect square trinomial. And right there I have a parentheses squared, and really that's what happens, like you'll see. So, go ahead, number one, complete or do this with me. So let's do this example. Ooh, they give us a crazy one. We're gonna do the same thing, solve by factoring, and then we're gonna check our answer. It's crazy. Watch. That's my y. Has a little tail. And if you do the steps we had way before at the very beginning, up here, right? Make sure you're setting it equal to 0. Most of the time they haven't had the greatest common factor. Make sure it's in standard form where A is positive. Identify the A, B, and C. Do the X and the box. Sorry, those colors didn't save. My iPad. Wow. Okay. So here, I want to make sure that it's set equal to 0. And I wanted my A value to be positive, so what I'm going to do is I'm going to move everything on this side. We're doing opposites. Basically, what the opposites does is this. They call them properties of equality. That's 0, 0, so that's now set equal to 0, and it's kept my A value positive. Okay. There are going to be some very large numbers, and we can do something. What did we call this before? They call this the chunking method. And I still think this chunking method is better than using the formula. So the chunking method says I take out this one and this one. 16y squared. And really this is 4y squared. Would you agree? And so I'm going to say that 4y is equal to x. Watch how we use this chunking method. So I can have, again, let's do that again, 4y. Now the square's on the outside, okay, and this one is going to be minus 12 times 4y. Let's see if this works, okay? Every time I see 4y, I'm going to write x. I see 4y, now I'm going to write x. I see 4y, I'm going to write x. Okay, what that did is I went from some crazy large numbers. So instead of me doing something like this, a times c, that would have been 16 times 46, you would have gotten some huge number. I've actually made it a lot smaller. And then I can just factor this. Let's just use that right here, what I got. Okay, a is 1, b is 46. So I got 46. And my b value is negative 12. So 46 and 1, 23 and 2. I think that's all we got on it. I can't add. As you can see, I can't add up here. That's 36. That might make my life easier. Let's try that again. 36 and 1, 2 and 18, 3 and 12, 6 and 6. So my winner, -6 and -6. Alright, -6 times -6 is 36, and -6 plus -6 is -12. So I have my box, I turn into an oval. And here, okay, we're not going to do our substitution yet, but let's use our colors to our advantage. So I have x squared I have -6x and -6x, which is right here, and then positive 36 is my c value. Okay, so now I'm just going to take out the greatest common factor of each row. And this would also be, so here I have x minus 6 equals 0. And then what you can do here is you can do your substitution. So we had said that every time we see x, we can write 4y. So now let's do that. I have 4y, there's 4y, and then you have -6. Okay, from here you can do two things. You can do something like this. You can put them together and then solve by the square root method. Plus or minus 0, well, we don't say plus or minus 0. If I take your wallet and add 0 to it, nothing changes. So you're just left 4y minus 6. We might as well call it just 4 minus y is 6. 4y minus 6 equals 0. And then add 6 divided by 4, which is, this would give you y equals 3 halves. Is your answer. You could have also here you could have separated them 4y minus 6 and just solve, and you'll get 2 of them. Y equals 3 halves and y equals 3 halves. I like that better because that kind of shows that there is a it's a double solution. The formula they like to give, which again I think it's just another thing. I'm not going to show you it too. It's just not fun. Do you want to see it? Okay, just because you asked for it. It's really not that fun. But hey, if you want to see it, a plus b quantity squared is a squared plus 2ab plus b squared. Yeah, that one looks fun. So I think the chunking method helps. It's a strategy we actually use in higher level math to make problems a little bit more simpler or more bite-sized. All right, for questions 21 to 23, go ahead and complete those two. Complete 2 and skip 1, and then solve each equation by factoring. All right, so let's go ahead and look at the chunking method here. You're really just looking at the fronts right here. And you're basically seeing what do they have in common. What they have in common is a 2x. So this will become, let's go go the other way. Any variable you want, I'll call it, I like w, I don't know why. W equals 2x. How did I get that? I got this from here. 2x squared minus 14 times 2x plus 49. And then every time I see 2x, I can write w. So I see 2x, I'm going to write a w. I see 2x, I'm going to write w. So you get this. And those parentheses go away, right? And then you can just do your A, B's, and C's, right? A is 1, B is negative 14, C is 49. Did anyone pick up the trick on this Xbox method? Okay, so you have A times C, which is 49. My B value is negative 14. My two numbers that have to be identical. Positive 7 and nope. That's going to be negative 7. Negative 7 times negative 7 is positive 49. Negative 7 plus negative 7 equals negative 14. So that represents the middle term here, so I'm going to add a w in there. You could have used x if you wanted to. And 49. That last term is always in the bottom there. And then greatest common factor, w, negative 7, w, negative 7. Okay, before you want to put back in the substitution, this might be a great time to put in your substitution. Every w is 2x, same color, and because you have two of the same thing, you don't need to do the problem twice. Add 7 to both sides and divided by 2, you get x equals 7/2. And that's actually a double root. Double root. You're just noting that if you did this same problem over here, you'll get x equals 7/2. So you're actually getting it twice. And remember, that's important because if you actually graph this, you want me to graph? 7/2 is 3.5, and basically, you know, you have the y-intercept c value, and it's going to go something like that. Does that make sense why it's called a double root? This actually represents two reals. And we forgot to check off work. Oh, yes. Okay, if you did that, I'm happy to check our work. So this will give me 4 times 49 over 4, 28 7/2 plus 49. So this will give me 49 times 4, 196 over 4 minus 28 times 7, 196 over 2. 196 over 4 minus 196 times 2 is 392. And 196 minus 392. And that's negative 196 divided by 4 gives me negative 49, which equals 0. Boop. Alright, number 22. 9x squared plus, don't do 7x, that's 6x plus 1 because they're not like terms. And then pick your favorite variable. I'll call mine y. Why, Mr. Ing? Why did you pick that? Well, if I put 3x in here, I'm trying to get the ones in parentheses to be the same, because then I can do this. Every time I see 3x, I can write y. I see 3x, right? Y. It just makes the problem a lot smaller. Now that one's doable, but I'm just showing you. And again, this only works when you can take out the greatest common factor, basically, of the first two terms. Okay, so that would give us this. A times C, my value is 1. B value is 2. 1 and 1. We're splitting this term here, and that one goes. Okay. Here, and then you take the greatest common factor. Y, 1, Y, 1, Y plus 1, Y plus 1. And then here, this is where I would do my substitution. And if you set one of those equal to 0 and solve, 3x equals 1. Oh, see? That's why you gotta go slow, Mr. Ing, Mr. Ing. Double root. Okay, let's do number 23. Set it equal to 0, same thing. Let's see if we can do this chunking method. Again, the chunking method only works for the first two terms. Let's pick our favorite letter. Let's pick W. What do you think it's going to be? What do you think? What do you think? What do you think? Well, something squared equals 16x squared. That's going to be 4x. Because we do 4x times what? 6, because we need 24x. Here is our substitution. So every time I see 4x, we're going to write W. 4x, we're going to write W. W squared minus 6, W plus 9. And now the problem is a little bit more manageable for us. So A times C is 9, B is negative 6, negative 3, negative 3. What are we splitting here? Okay, A is 1, or that always goes here. That one always goes here. So greatest common factor, W, negative 3, W, negative 3. Remember, you can always, you can multiply to check your answer here. W times W is W squared. W times negative 3 is negative 3W. W times negative 3W. W times negative 3 is negative 3W. And then negative 3 times negative 3 is positive 9. Whoa, that's a 0. And then here I'm going to do my substitution back in. write every w we see, we're going to write 4x and then just set it equal to 0. Solve, add 3 to both sides, divide by 4, careful, x equals 3/4. Double. Why is it double? Because you're basically doing the same thing again over here. Okay? Alright. Questions 24 to 26 basically do the same thing. Do 2 of them, skip 1, press pause. If you want to see me do it, well, just keep watching. What a nice blue that is. Wow, wow, dropping my pen. Alright, I'm going to set it equal to 0. Alright, I'm going to see if I can do a substitution for this one. So is there a greatest common factor for each of those? Yes, yes, yes. 9? What do you guys think? 9? Okay, so that would be 4, right? 4 times 9x plus 4 equals 0. So 9x is equal to W. You like W? Too bad. 9x equals W. Put it here, 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 here. So I get W squared plus 4 times W plus 4. And then do the X in the box. A times C, so this A is 1, B is 4, C is 4, so A times C is 4, B value is also 4, and my answer is going to be 2 and 2, so that is 4W, so 2W and 2W. This one always goes top left, this one always goes in the bottom right, and then we just take our greatest common factor. So W, 2, W, 2. You'll like those in the future. W2s, all your taxes. Write the binomials, set it equal to 0, solve. You could do something like that. That kind of looks weird, but you have 2 of them, right? Oh no, we haven't been checking our answers. 81. That gives me 81 times 4, which is 324. This will become minus watt 172. That does not sound right. Oh. Do you see why it doesn't make sense when I check my answer? Watch this. 324 minus 72. And I know why. 252. Is 252 equal to negative 4? The answer is no. They are not equal. Well, what happened? Hopefully you caught my mistake. Is we forgot to substitute back in 9x for W. That's what I forgot. Hopefully you caught that. That goes here, here, here. I think I even wrote it. Just, what are you thinking, my darling? Okay, so 2 up to 9x. So 9x plus 2 equals 0. 9x equals negative 2. X equals negative 2/9. So negative 2/9. Negative 2/9. This would be double, right? There's two of them. Last one right here would just be to cross multiply, really. But I'll show you what happens. 81 times negative 2 times negative 2. So 81 times 4, 324 over 81. This one's going to be negative. Negative 72 over 9, which I need to now multiply by 9 over 9. 648. It's supposed to be a negative. So 324 minus 648. This gives me negative 324 over 81. So divide my answer by 81 and get negative 4. Woo! Okay, greatest common factor now, set equal to 0. Yes, and let's see if we can do our chunking method. You guys see something in there? Just take the first one and really take the square root of it if you think about it. Well, if I want them to be 5x's, this is going to be 16. Favorite variable, how about y? Okay, so every time I see 5x, we're going to write y. I see 5x, write y. Everything else is the same. And then I can do this. X box. And A is 1, B is 16, C is 64, so A times C is 64. My B value is 16. My two numbers are 8 and 8. And we're splitting this one. So take greatest common factor of this row, greatest common factor of this row, this column, and let's not make the mistake we did last time, which was to do our substitution. Y plus 8 equals 0. And then every time I see y, I can write 5x. Now you can do this without the substitution. You're just working with super large numbers. Set that one equal to 0. Solve. Oops, that should be negative 8. And geez, Mr. 8. 5 just my brain dead. X equals negative 8/5. Double root. All right, 26. Add 5. Let me show you how it is possible to do this without the chunking method. Whoa, Mr. Hang, whoa. Okay, A, B, C. A times C is 900. My B value is 60. So I'm thinking 30 and 30. So that would be 30x. 30x. Do you realize how large these numbers are? Whoa. Let me check. Okay, let's see. 3x. How about 10? 3x and 10. So 3x plus 10. 3x plus 10 equals 0. And that looks like a 20. Sorry, guys. Sorry. So tired. Not an excuse. Alright, subtract 10 divided by 3. Here's another way of writing this. You can call this a multiplicity of 2. Basically says you have 2 of those. And we haven't been checking our answers, huh? Wow. So it's doable, it's just the numbers are super large. Okay, so square both of these numbers, that'll become 100 over 9. And this one's going to be, let me show you guys how I like to simplify these. It is cross canceling here, but 3 times 20. Why did I change 60 to be 3 times 20? Because I looked ahead and I realized there's a 3 down here in the denominator. Does that make sense why I did that? 9 divided by 9 is 1. So 20 times negative 10 is negative 200 plus 100. $100 bills, and it checks off. Wow.
Do you love math? If you do love math, I suggest to go to www.mrmathinc.net or YouTube Mr. Ing today. Very easy and compatible to work with.